So today we are going to start a new topic, and this deals with a transformation of interest rate, right? So far I have given you interest rate in a very simplistic manner. Most of the calculations that we have dealt is annual basis, right? I give you a 8% per year, 10% per year, 12% per year, whatever, and you directly use that, right? But the real world is bit tricky. Often people do not provide the good information for you to immediately understand the interest rate. And two examples I'll give you. One is, have you, any one of you heard of the app called 12% Club, P2P lending, but they claim that you will get 12% interest rate. What is that interest rate? Simple or compound? So by default in your whole world, your assumption is that it is going to be a compound interest rate. That's what you expect. But reality always checks in terms of conditions. People will mention in fine prints. So for example, this app called 12% Club, it's a P2P lending app with peer-to-peer. People can, the platform, it's basically you put money for your deposit. That app will make sure that if somebody needs money, they can come and they will distribute it. So of course, it's a bit risky business, but incentive for you to keep money there is 12% interest rate, which is highest in any. But it is actually a simple interest rate. It's not a compounding interest rate. So yeah, it can become an interesting play, and that has huge repercussions in terms of the overall profitability of the company and the business model itself. Equivalent app from what I think Cred is having some rate about 9% or something. So you can see 12% marketing play. Another example that you will commonly hear is from credit card company. So when you default, that's when you get to know all the fine prints. Never get default in your credit card, okay? These days it is a crime. Don't over borrow, and then this is a one seek you can take from me. But essentially what they mention is they will give right a rate of some 18% per year. But you will, in the fine print, they will mention that this rate is compounded daily, compounded monthly. So actual interest rate they will charge you would be much higher than this just 18% play. We will deal with such kind of problems in this particular, you will learn how to do, right? And it's also expected, right? Because annual is a very big enough period for a interest rate to compound. These days, so much transactions of money because of the digital transaction, calculating, estimating all these is become very simple. So people play with this much more often is what I believe, the kind of concept that we are going to learn today, right? So the idea is that most of the time, interest is not compounded annually. It can be compounded semi-annually, quarterly, even daily basis. Nowadays, almost every bank will give you a daily interest rate. Although they will tell you 2.5% per year, because per year is easy for you to understand. But back of the calculation is something that we will learn in this particular topic, okay? Bit tricky. There's a lot of notations that I will introduce to you. So follow with me carefully. If any point of time you're not able to understand, raise your hand and we'll clarify, okay? I'll go on this topic a little bit slowly. And we will also understand about the concept called effective rate versus nominal rate. Nominal rate is the rate which does not consider the compounding factor in place. So that's why people usually mention nominal rate. We consider this is an effective rate, but effective rates are much different compared to the nominal rate, and that's what we will see how to transform them. Okay, so far with me? All right. So some notations for this particular class. So first is interest period T. I will denote it with small t. What it means is the period of time for which the interest is expressed. For example, R percentage per T. So 8% per year. If I say that this is the interest rate, T is your year. When I say 10% per month, month is the time period that we're talking about, T. Okay? So far, fine. Then there's something called compounding period, which is called CP, compounding period. This is basically the shortest time unit over which the interest is charged or earned. So compounding, for example, can happen much quickly. I'm expressing the rate at 8% per year, but back of the day, I'm saying that compounding is happening every day. Means every day's interest accumulated is getting more interest like that. Or every quarter's interest is getting more interest like that, right? So that's what I mean by when I say compounding period, right? I will denote it with CP. So for example, if I make a statement that my rate is 8% per year compounded monthly. So here I am giving you some sort of a rate on a yearly basis, but I am also giving you information that this is not actually compounded on a yearly basis. This is compounded on a monthly basis. This is where the things become tricky. How do you handle these kind of rates in the real world? Okay. One notation, standard notation, which credit card companies do not follow, but in our course we will follow. If no compounding period is mentioned, your T becomes the CP. If I am not explicitly mentioning that this is the compounding period, whatever your T is becomes the CP immediately. So for example, if I say 8% per year, I have not mentioned anything. So my by default assumption is that CP is also year. The interest rate is compounding at an yearly basis. Okay, so far with me? Then there is something called compounding frequency, small m, which is basically the number of times the compounding occurs within a time period t. So essentially, for example, if I am saying 12% per year compounded monthly, my year is t, my CP is monthly, so m becomes 12, which denotes how many compounding periods in the given time period t. So here we are talking about 12 months in a year. 12% per year compounded weekly, T becomes 1 year, CP becomes week, M becomes 52. With me so far? T, CP, compounding frequency. I have given more red than there was originally present on this slide, but I hope you are able to follow. Alright. So these are some of the notations. Now we'll deal with, I'll also introduce another term called nominal interest rate. So nominal interest rate is interest rate which does not account for compounding. And then there is something, so this is basically the interest rate which does not consider the compounding effect into its definition, right? It's called nominal. Pay attention to the word nominal and effective. I will be using them more often when you see the examples, okay? So for example, what happens is for any period longer than the time period which is already mentioned, if you're dealing with only nominal rates, if you want to find, for example, I have given you nominal interest rate for month basis and I want to ask you that what will be the nominal rate for a yearly basis. You simply multiply that rate by 12 and you will get the yearly nominal rate. In compounding, this will not be true. If I am saying that compounding is happening monthly, you cannot simply multiply by 12. There will be another formula which will be dealing later, right? But nominal interest rate, you can simply multiply the n by the minimum unit that you have to get any other unit, or you can divide further. For example, if I'm giving you on a yearly basis, I'm asking you what will be the nominal interest rate on a monthly basis, you simply divide the rate by 12 and use that, okay? So, for example, if I'm saying that 1.5% per month and I want you to estimate the nominal rate for 24 months, you simply multiply and you can use that for every 2 years, the rate is 36% per 2 years. 12 months, it becomes 18% per year. 6 months, it becomes 9% per year. 3 months, it becomes 4.5% per year. Okay, but important, this is still nominal. It is still a simple interest rate. You are not taking into account the compounding in this case. So just to give you an idea, but most likely will not be using these formulas to directly multiply. Okay. Then there is something called effective rate. This is the rate when compounding of the interest is already taken into account. So this kind of rate assumes that by default you are dealing with a compounding problem, you are not dealing with a simple interest rate problem, and this is the rate we have to use in those kind of formulas, right? Now here becomes the very tricky things. I'll start introducing you, right? So typically it is expressed on an annual basis if you are interested in doing the calculation on annual basis, right? So if most of the transactions that are happening on the problems that you have solving in your assignment so far deal with the annual transactions, right? So whatever rate I give, ideally you should be using an annual equivalent rate, and that will be put as into your formulas and whatever, right? So that's the basis thing, but it can be made more complicated. I can mention compounding period. So I can say R percentage per time period and compounded CPL. This is just a notation. This is of course to make it clear for you. So this is the more comprehensive way to define a effective interest rate. Using this information, you can calculate effective interest rate for any time period, is what I'm planning to say here. Alright, let me give you more example. The idea is, if CP is not stated, if I'm not giving you any information on compounding period, you assume it is to be same as the time period which is mentioned with respect to the interest rate. For example, when I'm only giving you 8% per year, it means that your compounding period is also year. In that case, if I'm asking you to do only on yearly cash flows, you can directly use the rate. If I'm asking you to use this rate on some different type of cash flows, for example, monthly or 2 yearly basis, you need to change the rate. Okay. So I'll give you some example. For example, when I make a statement, simple statement, if I make 10% per year and I'm not giving you any other information, it means CP is not stated. It means CP becomes equal to the time period that I'm giving you. So it means this is a effective rate that you are going to use for all yearly cash flows. Okay, that's by default in this course. So don't come to me, sir, you didn't say nominal or effective. If it is, I'm not, only these terms you will see when I actually want you to do that kind of transformation, or I am trying to mislead you to do that kind of transaction. If nothing is mentioned, you simply assume this is the normal interest rate that you have been dealing with so far, right? So in that case, it is a 10% per year. If all your analysis required only an yearly rate, you can directly use this rate. Not a problem. If not, you will need to change. How? I will give you some ideas. Okay? So far with me? Suppose I make a statement. Effective 10% per year, compounded monthly. What is T here? T is year, CP month. But I am mentioning the term effective. It means at the back of the calculation, I have already done whatever the compounding effect will come. If you want to use this rate for yearly, you can already use, doesn't matter what is CP. Only for yearly transaction you can use, because this is effective rate per year already given to you. Understood? If you need this information, for example, if you need to estimate for quarterly rates, we will have to do the transformation. I will give you how to do the transformation later. So far with me? 1.5% per month. What is T? CP? Not given. So it is month. So if you want to use this rate for monthly, you can straight away use this rate. This becomes your effective rate for monthly transaction. For any other transactions if we want to do, we will need to transform this. We will see how. Okay. Effective 1.5% per month, compounded monthly. T, CP, basically no needed. You could have just avoided mentioning. It's redundant information. You don't need to do anything. Again, this is an effective monthly rate directly given to you. Straight away use it for monthly transactions. Okay. Finally, effective 3% per quarter, compounded daily. What is T? And CP? What is M? Yeah, those kind of problems will also come. Somebody will argue, sir, there are 365 days in a year. How do you divide them evenly on a quarter? So I will say 91 days instead of 90 days. Yeah, we can all argue about that, but by default it is 90 approximately. This is what we will be dealing with, or you can be more precise, 91.25, and then adjust for leap year or whatever you want to do, you can do. But here essentially you have mentioned the rate effective 3% per quarter, but in this case the compounding is happening on a daily basis. So if you are dealing only with quarterly transaction, you can directly plug in this rate. Otherwise we'll need to transform, and we'll see later how to do this. Okay, clear with the notation? If I'm not mentioning anything, by default is an effective rate. If I'm mentioning nominal, then only you need to take it as a nominal rate. If CP is not stated, it is equal to the same period at which the rate is mentioned. Okay, so far okay with the notations? This is I will come back to, we'll end this lecture perhaps tomorrow with this kind of a message. But the idea is, I'm actually straight away right now giving you, there are two ways to deal with transforming the rate. Either you make the rate compatible with the time period, or you change the time period to make it compatible with rate. In some cases, both of these transformation will give you the same answer, but one of them is inherently wrong. So by default, never change n, never change the time period for transaction. Always modify the rate, bring it to the necessary calculations that you need to do and use them in the formula. Don't change n, don't change time period, don't make it that a habit, because in some cases you will be able to get the correct answer, but it is not correct. I will show you how towards the end of this lecture, perhaps tomorrow we'll be reaching there. But all interest formulas, factors, tabulated values and spreadsheet function, they must use an effective interest rate to properly account for the time value of money. Okay, so take it as a by default that you always need to transform the rate to suit your calculation needs, not change the period or the number of years to suit to your given rate information. Okay, so what is the relationship between an effective rate and a nominal rate? Okay, so pay special attention to this. Effective rate per compounding period, effective rate per compounding period is nominal rate, which is whatever in percentage per time period t, divided by the m number of compounding periods in the time period t. I'll give you more examples. Effective rate per CP, per compounding period, equals to nominal rate per time period t divided by the number of compounding periods m in that time period t. Okay, and it is denoted by r by m. This m is same as the one we saw in the beginning, right? Number of compounding periods in the time period given t. Okay, so far with me in this formula? Alright, let me give you some examples. Suppose I say that the notice on this table, these are all nominal rate per t. I have given you a compounding period. I am asking you to calculate effective rate in the same compounding period. Okay, so let's say if a rate is 9% per year, compounding is happening in a quarterly basis. What is the value of m? 4. So your effective rate per quarter becomes 9% divided by 4 is equals to 2.25%. Graphically, this is denoted using this kind of a, so within the period 1 to 2, the rate is 2.25%, 2.25%, 2.25%, 2.25%. With me? We are always, in this case, be careful, you are always transferring, the t value is higher than the CP value, right? You are not doing the other way around. You are not, if compounding is happening every 2 years, you are not transforming an yearly rate to compounding period. It's in this case, CP is always less than t, right? That's what we are doing so far. If it is 9% per year, and I say that compounding is happening every month, m becomes, so the rate becomes 0.75%. Graphically, it is denoted using this kind of a series. Okay. If I say it's 4.5% per 6 months, t is equals to 6 months, and I am saying CP is weekly. What is m? Don't tell me that I did not teach this formula. How many weeks in a year? Okay. Don't tell me that this value was not given, so I could not use. Okay. So your rate essentially becomes what? 4.5 divided by 26. Check if it's the correct value. So far with me, able to understand? We are always transforming a higher rate time period mentioned to the compounding period in the case where t is always greater than CP or equal to, then you don't need to transform. And this is a nominal interest rate. Okay. Now, how will you use this information? Suppose I give you an idea that I am giving you 8% per year and this rate is getting compounded quarterly, right? So, if you want to use for quarterly transaction, you divide this by, this is your rate that you can use for quarterly transaction, whatever. For any other transaction, you need to convert this 2% to an equivalent rate, which we will tell you how to find, and that will be the rate that you need to use. Okay. For effective rate is stated, which is effective 8.243% per year compounded quarterly. Yearly transaction, directly you can use this rate because that effective value is already given to you. For anything else, we will need to transform it. I'll show you in the next couple of slides how to do that. Okay. Simple 8% per year. CP? Not mentioned, so year, and nothing else is mentioned, so it is basically an effective rate because it is no nominal or nothing is mentioned. So 8% per year for all yearly transaction, straight away do it. Okay. For everything else, we will find effective rates. Cool. All right. Now, let me give you a simpler example and then I'll generalize the formula. Suppose your problem is that I want to find effective annual interest rate. I have given you whatever we are dealing with a smaller unit, only let's say I have given you an effective monthly rate. Using that, how will you find effective annual rate? Right? Suppose I gave you 8% per year compounded monthly. Now I want you to tell me what is the effective annual rate for this. So first you will do is transform it back to the monthly equivalent, monthly effective rate, which will be whatever 8 divided by 12. And then that rate you will need to again project back to yearly. How? I will show you right now. Alright. So again the symbols more or less same. Let's say R is the nominal interest rate per year. CP is the time period for each compounding period, which is CP is always less than the T that you are dealing the case here. M is the number of compounding periods in a particular year. I, the small I, is effective interest rate per compounding period, which is R by M. Clear? Why it is coming R by M? IA is the effective annual rate which we need to find. You understand the problem? Now we are transforming from a lower time period to a higher. In the previous slides, what I gave you is using the nominal interest rate, how do you downgrade to a smaller CP? Now that we know an effective rate on a smaller CP, how do you project it back to a longer time period is something we are dealing with. You understand how the problem is transformed? This is the kind of equation. Solving this equation will give us an idea. What I have done is, let's say there are m number of computing periods. So in each of those m, my intermediate interest rate is by this small I, right? This you already know. M is given, I is already R by M given to you, right? So let's say whatever this m number of period is, let's say you denoted some p value in the beginning and you want to estimate the final value of A, or at the end of the 1 year, what will be this value of P. So for first period, this is invested at I% per whatever the time period. So the value here becomes P into 1 plus I. In the next period also the rate is I, so it becomes again 1 plus I square. At the end you reach 1 plus I to the power M, right? And what I am saying is, instead of all this, if I want to use one single effective rate, which is equivalent to for this entire period. So my formula, the same P value will become what? P into 1 plus IA. Making sense? I have calculated the future value using two methods. One is intermediate period. For each period we have a small I rate. We can calculate that formula P into 1 plus I to the power M. But I am asking you in finding an effective rate, that rate would have been a single period, and the rate would be IA. So the future value for that will be P into 1 plus IA. All I am doing is equating both of them, because if I am saying that this is an equivalent rate, the future worth computed by both the methods should be same, right? So your equations become IA is equals to 1 plus R by M to the power M minus 1. Follow? I'll just derive it for you if you are a bit confused. You need to estimate IA. IA is 1 plus I to the power M minus 1. Okay? This I is R by M. With me? 100% clear. No mistakes in this. Let's see. This formula you might have to remember. If not, you can always derive from this kind of a. The reason I am giving you this simple derivation is, in case you are forgetting, please use these simple methods to get your zeal back. Okay. This is a very special case when I say that M tends to infinity. There is a very special case called continuous compounding. Right now we are dividing your time period into a very discrete events, right? We are saying a month or a daily basis or whatever. So we are saying today is one day. At the end of the day, only the interest rate will be computing. But the time is a continuous variable. Second is also even a discrete. Like there could be millisecond, nanosecond, blah, blah. It's a continuous unit. So whatever you are doing, you are actually always discretizing it. But there could be actually many situations where they say something called a continuous compounding. What does it mean is M becomes too large. M tends to infinity. Right, because you are having very nano, picto, whatever that time, so your capital M will become very high, but this value will also become very high. So this term will tend to 0 when M tends to infinity, and this term tends to infinity, right? So this is again, I am not deriving this formula. This is a classic limit problem that you have solved in your 12th class. I am hopeful that you have solved that in your 10th class. And in that special case, this becomes a logarithmic series. And the answer is, if you want to calculate the continuous compounding, you need to use this formula, is e to the power r minus 1. Only this special case. You want to memorize or not? Okay, but you understand what I am trying to say. So you can also have this kind of issue when they will say that interest is compounding continuously. So then you need to use this formula to transform. It's a very special case. Your calculator will never have M is equals to like some 1 million, you will never be able to calculate power 1 million of a particular thing in your calculators, right? Perhaps Excel can do, but idea is this. You can actually try on this on your own also in Excel. Write this formula and change for each value of M and see how the formula reacts, whether it converges to e to the power r minus 1 or not. Okay? Let's see an example of what is happening. So, my original rate is 18% per year, and compounding CPL. In each cases, I will vary the CP and we'll see how it has an effect on effective interest rate on an annual basis. Alright. So my time period is 1 year and CP in each of these things will be changing. So when compounding period, let's say in first case is year. So your M becomes what? 1. Your rate per compounding periods become what? R by M. Doesn't change, 18% per compounding period. This is the kind of formula you're dealing with. You put the value 1.18, which is 1 plus R by M power M minus 1, which I have also given to you. So 1.18 power 1 minus 1, so 18%. Formula works. That's the validation that, of course, an 18% per year compounded year, the effective rate is yearly. So that's how the formula works. At least that's the proof. It's not a proof, don't use it, but yeah. Don't say I told us this is a proof of the theorem. No, it is not. Let's say a case of compounding happening every 6 months. So what is M? So your effective rate per 6 months, what it will be? R by M, right? Put in the formula, you are getting the final effective rate to be 18.81%. Originally, this is what the credit card company mentions. This is what they charge. The more infinity you go, you'll see the 18% rate actually becomes about 19.68, which is 1.5% higher. It can has a huge influence on your overall financial statements. 2% rate change is not a easy or minor fluctuations when you're dealing with slightly higher amount, right? Got the idea how the calculation is being done? Suppose the quarterly, the CP is quarter, right? What is the M? What is the effective rate per quarter? 18 by 4.5%. You put in the formula 1.045 to the power 4 minus 1 comes out to be 19.252%. Okay? Why this formula is coming, everyone is able to see? It's 4.5%. So in this, we are putting in fraction. So that's how it's. Do not get confused. Sometimes you need to define percentage in fraction. It's used interchangeably in this form, in this class. Month, when compounding period is month, M becomes, R by M becomes 18 upon 12. What is 18 upon 12? 1.5. You put the formula here. Your answer comes out to be 19.562%. When I am saying week, oh, this is not even infinity. Sorry, this is just a weekly basis. M becomes 52. R by M, I'm assuming this value because I've taken this as a screenshot from a book. And finally, you say the 19.684%. This is just on weekly. Can you give me an infinity one answer? E to the power R minus 1. Not confident in saying your answer anymore. 19.72%. Yeah. So you can see the more smaller your compounding period is, your effective interest rate is actually going higher and higher. That's how people trick most of the time. They'll mention on a year basis, but on the fine print, they'll mention the compounding is happening on weekly basis, daily basis, whatever. Can you find the daily interest rate? M becomes 365. Can you give me the answer? 19.771. So still continuous is slightly higher compared to the even the daily basis. So you will always notice when bank has to lend you money, they will do this kind of things. When they want money back from you, they will be very sure to mention effective rates and all those things. But at that time we do not, because the term effective is like, okay, what is something is happening, we don't need to worry. And a general person does not get to like worry about it, all these problems, but it happens. Every credit card bill statement you start taking, you will find these kind of fair word play in the fine prints. Okay, clear? Concept wise clear? I'm going to make it more complicated. So far we were doing it on a yearly. The transformation was from a nominal yearly interest rate. We came down to the CPL effective rate. We transformed it back to an effective annual rate, right? I am generalizing the formula now, which says effective I for any time period, whatever, let's say t, can be denoted using this formula, 1 plus x to the power m minus 1. Okay. In that case, the x is the effective interest rate over whatever compounding period is given to you. Compounding period becomes your unit where you have to transfer and then transfer back. Always look for the compounding period information. So x is the effective interest rate in any compounding period, and M is always the number of times that interest is compounded per time period on the left hand side of the above equation. Okay, so M is always this T by Cp. T is whatever is mentioned here or whatever you need to estimate. This formula is generalizable. Similarly, what we derived for annual, you can actually derive. I'm not deriving it for you, but this is the generalized formula. And this works both ways. If you want to convert from weekly to yearly versus yearly to weekly, this formula works both ways. The M can either be 12 or 13, no, or whatever. M can be either 52 or 1 by 52. The formula works. That's the beauty of this formula, because it's a symmetric. All you need to do is take -1 here, then take a 1 by M root, and then you can actually derive. So the formula remains a general formula. Okay, should I explain it again? Your X is this term. X is always the effective interest rate per compounding period which is mentioned in the question. Okay, and M is always the number of times that interest is compounding in the time period which is mentioned on the left hand side of this equation, which will be governed by your problem statement essentially. I'll give you examples. I'll give you examples of the wordplay, but remember this simple transformation: T 1 plus x to the power m minus 1. X is r by m, but the m is the value which is only in T, not in the whatever other units you are doing. M is T by Cp. Okay, follow with me. I will take you to the more complicated questions and let's see what's happening here. All right. So Tesla Motors manufacturers a high performance battery vehicle, not anymore, but an engineer on Tesla committee wants to evaluate bids for new generation coordinate measuring machinery to be directly linked to the automatic manufacturing of high precision vehicle components. None of this is useful to you, but that's how the questions are formed. Here, 3 bids include the interest rate that the vendor will charge on unpaid balance. So actually interest rate in some of the contracting, that becomes the primary evaluation. So everything else is fixed. How much interest rate will you charge in order to get this work done? So only the evaluation happen, the higher the interest rate, less favorable for you because you need to pay better, right? So 3 people have included this bid, whatever interest rate bids related to them. As a person, you need to evaluate what is going to be the better for me as a company, right? To get a clear understanding of the finance cost, Tesla management asked the engineer to determine the effective semi-annual and annual interest rate for each bid. I don't know why this Tesla management is asking on effecting semi-annual as well as an effective annual, because you can make a decision on any one unit. It's not going to change. But yeah, I think this Tesla management would have been my brother or something who wants to make your life complicated, right? So the bids are as follows. The bid 1 is 9% per year, compounded quarterly. This is what one vendor quoted. The second vendor quotes 3% per quarter, compounded quarterly, and the bid 3 says 8.8% per year, compounded monthly. Okay, you have to find effective semi-annual and effective annual interest rate to compare. Question is clear? 3 bids, each of them have assumed something to confuse you, but you are clear that we need to bring all these interest rate into a single time of frame, which is semi-annual or annual, and that's the question, right? So determine the effective rate for each bid on the basis of semi-annual periods. What are the effective annual rates? These are to be part of a final bid selection. Which bid has the lowest effective annual rate? So pretty simple question that thereafter. Understood the question? All right. The first part. So we need to identify the bids or convert each bid into semi-annual periods. So the time that you are interested in is what? 6 months. Doesn't matter what the vendor has quoted. You are only interested in 6 months, right? But each vendor has given you the information on the CP period. That is something which you are interested in, that they have already given to you. So what does the X becomes? What does the M becomes? Or 4? Why not 4? But he has said 9% per year. CP is month, T is 6 months. So CP is quarter, T is 6 months. But why are you not taking M as 4 is my question. The vendor has clearly said 9% per year. For calculating X, you have to take M as 4, and so that's the tricky part here. First, you need to convert using the information given to you to your CP unit, right? There are two transformation happening. First, whatever the vendor has given, you are bringing that rate to whatever is the CP that you desire. Then you are shifting this rate back to the time period that you are interested in. There are two transformation happening in any of these formulas. It's not a simple transformation. So the first one is dependent upon the 9% per year. For that part, for this particular part, you have to use M equals to 4. So your rate becomes 2.25% per quarter. R by M, M becomes 4. But now you need to transfer it to only semi-annual basis. This is what your desire. So then M becomes 2 quarter. So your I effective per 6 months become this particular value. Clear or not? Always remember there are two transformations happening. First, you are bringing the original rate to the CP that you desire, the nominal to the effective per CP. Then you are using this CP to calculate for whatever time period you are interested in. Right? You as a company could be interested that I want for per 3 years. But that's not how vendors work. Vendors deal with money, or they deal hundreds of clients every day. They cannot keep on calculating for each client differently. So they have a standard way to report their rates. Right? So that's how these things come, because people keep on changing what is most suitable for them. But you, when you have to do the analysis, you need to bring everything on a single page. Clear? Making sense? So the answer is 4.55%. Second case, 3% per quarter, compounded quarterly. What is CP? What is effective rate per CP? 3%. What is your final target period? How many M's? Tell me the answer. Oh my God, you have become super fast, huh? Everyone getting the same? 100%. Half of you are not even calculating. 8.8% per year, compounded monthly. What is T? T that you are interested in, what is that? 6 months. What is CP? CP is month, right? So what is the effective rate per month? 4. What is 4.88? Per month. Effective rate per month. How can it be 4.88? What is this? 8.8 divided by 0.73%. 6 months. So you need to use this rate to finally transform to, what is the M in this case? Because your CP is 6. CP is the month and you are transforming into T is equals to half an year. Making sense? So there are two steps in every calculation that you are doing. First, you are bringing to an effective CP for whatever the external information was. Then you are converting that rate to what is your desirable output. Okay? Alright. So now if I know the semi-annual rate, what is the easiest way to calculate the annual rates? Into 2. These are effective semi-annual rates. How do you calculate the effective annual rates using them? Into 2, how many people? How many people into 2? Nobody? Only you? Go, don't worry. Yes, you are wrong. But the idea is you simply now here there's a time period becomes 2. Your semi-annual rate is already on a CP. CP becomes 6 months. Your T, the target T is 1 year. So M equals to 2. So all you need to do is put into this equation and you will get an effective annual interest rate for each of these values that you have done. Multiplying by 2 would have been wrong because this is not nominal interest rate. You have converted it already to an effective interest rate, right? When you are dealing with this formula, you are already converting into an effective interest rate. So this formula is working. X is your effective interest rate over the compounding period CP, and M is always the number of times the compounding needs to happen per period on the left of the above equation, and the left is what is governed by what is your desired output. I'll just give you a simple answer and we will conclude this lecture here. So let's say the nominal interest rate is 12% per year, compounded quarterly. The effective rate per week is what? So 12% per year. CP is quarterly. So your effective rate per quarter is what? 3% per quarter. Now your target is week. How many quarters in a week? 1 by 13 becomes your M. The answer comes out to be on a weekly rate. M is always the number of compounding periods in the time period mentioned on the left hand side of the equation. So left hand side of the equation is week. So how many quarters in a week is the question that you need to answer here and get. Makes sense, right? If you do it 13, you will get weekly rate to be so high compared to quarterly rate. How can it be true? So it's a check for you, immediate check for you. You can make sense out of the numbers being calculated. But in Excel, you won't, I know. So that's a pointer for you. Alright, so this is where I will give you these rates. I will advise you not to use these numbers in Excel anymore. Yes, Excel has formulas, effective and nominal, extremely confusing formula. I will not advise you to use it. Do this calculation more or less manually and at least set up the formula. Formula estimation you can do in Excel. Do not use the direct effect and nominal because this is only done for annual basis. So you'll not be able to handle all other cases using Excel, or you need to transform too much and then you will get confused in a more convoluted problem. Okay? Alright, so this is where we will stop today.